In this video, we're going to utilize data to form a Pareto chart of sorts to analyze where the biggest bang for the buck is in fixing defects or problems. And so it presumes quite a few things. It presumes that the only defects you want to fix are RMAs and are based off an NCR log. But it'll show you the methodology in order to solve a problem. And then you can apply that where it seems to fit for your organization. If you're not familiar with a Pareto chart, it looks something like this. This is just the one from Wikipedia, where it shows the largest volume of defects to the smallest volume of defects. And so you kind of start with the top down and solving the biggest problem first, and eventually eliminating all defects. And that's part of the Six Sigma DMAIC process. And so first thing you have to do is define what problem you want to solve. It's the D in DMAIC. And by doing that, you have to analyze some data. You have to capture some data, analyze some data, and make some decisions. I already said that the defects are a bar graph that start large and end up small. What is this line graph, you might be asking? That's the accumulation of the defects. So if I added porosity onto shrink together, they account for about 80% of the defects. And etc. And you can see how they slowly increase to 100% as you do this. And so let's minimize that and let's look at some sample data. I went ahead and created some sample data. It's pretty randomized, just kind of based out of my head. Presumes quite a bit of things. For the sake of this, it's every row is going to be a closed NCR customer RMA. I threw some corrective actions in here. They would probably follow a naming convention, something like that, depending on what ERP system you're utilizing. And so what you want to do is you want to be able to analyze this data, because otherwise it's just a spreadsheet. And people often wonder, why do people geek out over spreadsheets? And so I'm going to show you how to utilize valuable data that you're capturing to look towards process improvement. So one of the things that you got to be able to do is be able to read it clearly. And so if you use a formula, the mod formula, and let's do row, and what we're going to do here is we're going to look towards alternating background colors. It's already going to make your data a lot easier to distinguish. And so now you can see you've got alternating row colors. The next thing you're going to do is filter your data. So you go to the data tab, ribbon, they call them in the new ones, and filter it. So you can say, okay, I just want to see things that are out of tolerance. Or I just want to see out of tolerance for diameter and threads and location. And so this will help you to manage your data better. You can also sort, so you can say, hey, I don't want that, and then I want to sort them based off of that, or descending. And you can see how it affects your data. Let's see here. Okay, so what you need to do is you need to extract some value out of this data. And so what problems are you trying to solve? And so what you want to do, what I like to do is I like to do a pivot table. And so what you'll do is go to Insert and insert a pivot table. Create a new sheet. And then what you're going to do is you're going to figure out what row and what column you want. So my column is for sure going to be return quantity, or values rather. And let's just start with category for our rows. So you can see here that we're utilizing the sum of our return quantity. And you can see that we had 80 pieces returned for bad finishing or a problem with finishing, 395 pieces returned for being out of tolerance, and 165 pieces returned with packaging issues. Depending on your data, you could actually have really high sums, but really low actual counts, instances. And so you can change this from sums to count, and that will give you your instances. And now you can see that there's a greater discrepancy between it. Three shipments had issues with finishing, 5 shipments had issues with packaging, and 15 shipments had issues where they were out of tolerance. And so obviously your Pareto chart would look like you'd have your 15 from your, let's just do it like this. Let's say you got 15 from your out of tolerance. Let's just do it based off instances. Then you've got 5 based off of packaging, and then you got 3 based off of finishing. And your broken line graph will be up in here. So just by quickly examining this, you know your biggest bang for your bucks is fixing your out of tolerance items. These are problems to solve. Maybe they're easy problems to solve. Maybe if Dave Ramsey was leading our lesson today, he'd say use the snowball method and start with the small and build momentum. But you got to stop the bleeding, and that's how manufacturing works, is you have to stop the bleeding. The other thing that you want to do is, let's take a look at, instead of category, let's break that category down a little further into the reason for return. And now you can see that you've got different things at stake happening. And so if you were to try and concentrate on areas, probably threads would be the first area that you are concentrating in knocking out this big giant of out of tolerance. Because you could have subcategories of different types of issues, and again, this is presumptuous of root cause. Were the threads good before plating? Did they come back from plating bad? Did we not check them? Do we have continual thread issues? How can we change our process? So, we haven't got to root cause. We just are based off reporting data. And so once you determine root cause, then you can work on a fix, and you have to follow the rest of the DMAIC process to determine how all of that plays out. But the goal of this one is just to kind of open your eyes to the Pareto chart and how looking at your data could influence where your next step is. You can't just let it continue in the common status quo. You have to make some changes. And when you get good, you might not need to look at a Pareto chart or even a pivot table. You might be able to assess it a lot quicker by sorting. So you may come to category and just say, hey, let's look at what all the out of tolerance stuff is, or even let's show all of the out of tolerance, but let's sort it. And you can see here that there's a lot, there's 5, and there's 3. The same thing is true with quantity. If you quickly highlight that data, you can look down here and you see you got a count of 15 and you got a sum of 395. So quickly being able to assess your data is a great way to handle it. The other thing that you're going to look at, is you opened up corrective actions on these 5. For whatever reason, you didn't determine that these needed corrective actions. And so because they didn't, then maybe it was a one-time issue, maybe it was a fluke, maybe the root cause determined that it was something beyond your control. Sometimes you just are returning parts to make the customer happy. You've measured it 15 times sideways. You did it on your height gauge, you put it on the CMN, you put it on your visual system. The part is a good part. But if this customer is responsible for $2 million a year in business and they want to return $1,000 worth of parts, you're probably going to let them. You're probably just going to keep them happy. That can happen. Perhaps they have someone new on their quality team that's measuring parts differently than the way you've measured them or differently than what you've seen. And sometimes measuring a part differently is going to get a different result. So it's important to be able to know that, have those relationships and those communications to figure out why things are the way they are and look towards process improvement. But again, the customer is usually always right, and your job is to keep them happy as well. So not a popular opinion in this day and age, but it's a successful opinion. So let me sort this again. And let's look at a couple other formulas. So this customer NCR log should have some level of formulas in it. And so you've got a target data closure right here. And so this is just a formula that just says whatever the date of reporting is plus 7 days. This date closed is a math equation that I just arbitrarily made up. But if you subtract this cell from this cell, then you can see how many days open it was. So the more you can automate your formulas and your sheets, the better your data is going to be, and the better chance you have at solving problems. And so as you just find out that there's an issue, it's been reported, you create your RMA, you determine the responsibility, the customers and the part numbers and the revision are pretty apparent, as is the requested return quantity. Usually for us, before we generated the RMA, we would pull something from inventory or from the MRB cage, and we would measure it and just see if we could replicate their results. More often than not, we could replicate the results, and so then we would find it there. If we couldn't, then we would just ask them for more information, and that's where the customer relationship comes into play, and being able to work together on finding a problem or finding a solution to a problem. They don't want to return stuff. They know it's extra headache for them. It's extra headache for you, and so they just want to know that it won't ever happen again and what steps you're taking to make sure it never happens again. And so once it was into our system, it's been validated, it's been authorized, they've got a reason that they want to return it, and that's there. And then we start to categorize those things. And so highly recommend having some generic categories for the reason for return as well as the category. And you can always grow on that. And the beauty of Excel is whatever you start typing in here, once you start typing again, it's going to autofill based off of what it sees as a pattern in that column. And so all of these things these reasons for return can be categorized more broadly into what's called a category in our NCR log. And the category is super important because it allows you to group things and attack it from the largest to smallest. There's going to be a disposition. A lot of the times, whether or not there's a corrective action will be determined on the disposition. Is it something we could quickly rework and then make adjustments on the fly and fix our process once we've determined root cause? And so there is an investigation that happens. Even if it's not a formal corrective action investigation, the corrective and preventative action processes should be followed, even if they're not going to be formally followed, they should be followed informally. And all of your NCR, customer NCRs slash RMAs should be closed. And so certain ERP systems determine NCRs in different ways. Some of them, every time you create a piece of scrap, it's going to document and save that NCR. That's good data, and that's a great ERP system. Again, you have to determine what level shows up on the radar of the owner, what level shows up on the controller, what level shows up on the production manager, and what level shows up on the shop floor, the AM supervisor, PM supervisor, quality supervisor, who has visibility to which things and for what reason. You can't boil the ocean, and everyone can't see everything all the time. So you have to divide and conquer. You have to delegate those things. So you got a target data closure, and then you've got an actual data closure. And again, you don't want to be doing any math you don't have to do. Whenever you can automate a task, you want to automate a task, and especially with an Excel formula that's proven. And then you dot control your form. So, and yeah, there's other things you can do too. Is perhaps if you have a kappa, you can do some conditional formatting so that if this text contains a Y, then you're going to make it show up red, and that way it's going to draw your attention to the kappas. If this stays open, you can do all kinds of formulas. So you can do this, minus today's date is greater than 7. Then you can make that whole row show up red, however you want to slice it. But just start looking at your data, start analyzing your data, and start figuring out what problems you're trying to solve. All right, hope this helps.